Four types of segmented processor. Code Segment Register, or CS, is used for addressing memory location in the code segment of the memory where the executable program is stored. Second, Data Segment Register, or DS, point to the data segment of the memory where the data is stored. Third, Extra Segment Register, or ES, also refers to a segment in the memory which is another data segment in the memory. Fourth, Stack Segment Register, or SS, is used for addressing stack segment of the memory. The stack segment is that segment of memory which is used to store stack data. Fundamentals of a processor. Processor design is the design engineering task of creating a processor, a key component of a computer hardware. It is a subfield of a computer engineering design, development, and implementation, and electronics engineering fabrication. Design process involves choosing an instruction set of a certain execution paradigm and result in a microarchitecture which might be described in IE, VHDL, or Verilog. For microprocessor design, this description is then manufactured employing some of the various semiconductor device fabrication process resulting in a die which is bonded onto a chip carrier. This chip carrier is then soldered onto or instead of the sucker on a printed circuit board. The instruction set. The mode of operation of a mini processor is an execution of list of instructions. Instructions typically include those to compute or manipulate data values using registers, change or retrieve value in read-write memory, perform relational tests between data values, and to control program flows. Processor design are often tested and validated on a FPGA before sending the design of the processor to a foundry for semiconductor fabrication. In computer science, an instruction set architecture (ISA) is an abstract model of a computer. It also refers to as architecture or computer architecture, a relation of an ISA, such as a central processing unit (CPU) is called an implementation. In general, an ISA defines the supported data types of the register. The hardware support the managing main memory fundamental features such as the memory consistency, addressing model virtual memory, and the input-output model of a family of implementation of the ISA. Single cycle processor are what we have been studying so far. An instruction is fetched from memory, it is executed, and the result are stored all in a single clock cycle. The benefits of a single cycle processor is that they tend to be the most simple in terms of hardware requirements, and they are easily to design. Unfortunately, they tend to have poor data throughput and requires long clock cycles, slow clock rate in order to perform all the necessary computation in time. Data path and control. Data path is the hardware that performs all the required operation, for example, ALU registered and internal buses. Control is the hardware that tells the data path that to do in the term of switching operation, selection data, movement between ALU components, and etc. Segmentation pipeline. Segmentation pipeline was developed with a focus of enabling the make fast and simply declared experiments which can be easily stored, reproduced, and compared to each other. Segmentation pipeline was as a lot of common parts with generic pipeline, but it easier to define an architecture of the network. Also, there are a number of segmentation specific features. The pipeline provides the following features: allowed to describe experiments in a compact and expressive way, provides a way to store and compare experiment in order to methodological find the best deep learning solution, easy to share experiments and their result to work in a team, experiment configuration and separate from model definitions. It is easy to configure network architecture, provides great flexibility and extendability via support of custom substance. Common block-like architecture called block model matrix provides visual and others should be written once and be part of a common library. Ideal operation. Ideal pipeline performs implemented completely in hardware, exploits parallelism and its sequential instruction stream. Invisible to the programmer, not so for other forms of parallelism. We will see. Not invisible to programmer looking to optimize. Compiler must become aware of pipelining issues. All wooden machines use pipelines, widely used in 80s, multiple pipelines in 90s.